So we're going over 6.3, solving systems by elimination. So we're going to simplify each expression. We start off with 1, so we're going to simplify the 3x and the 5x. We're going to combine them into negative 2x. And we're going to combine the 2y with the negative 2y. But because they are the same and just different signs, we're going to subtract them. So we're going to end up with just negative 2x, as the 2y's would become 0. Now for the second one, the first step would be to distribute the 5 into 5x minus 5y plus 2x plus 5y. Now I'm going to go ahead and combine the terms, the x's with the x's and the y's with the y's. The y's happen to cancel out just like the first one did, and the x's end up being 7x. Now for this third one, I'm going to start by distributing the negative 3. So we're going to get 4y plus 6x minus 3y minus 6x. And I'm going to start by combining the y's and the x's. You notice the x's cancel out, so you're only left with 1y or just y. I will, for number 4, distribute the negative 2. So I'm going to go ahead and do 2y minus 4x minus 8y plus 4x, and then combine all the terms. Now the 4x's cancel out, and the y's combine to negative 6y. All right, for 5, 6, 7, and 8, we're going to take the least common multiple. The way you do it is, for example, number 5, the multiples of 3 are 1 and 3, and the multiples of 6 are 1 and 6, 2 and 3. Now, the smallest number that matches are 3 for both of these, so we know that's going to be 3. When we do it for 6, the multiples of 4 are 1 and 4, 2 and 2, and the multiples of 10 are 1 and 10, 2 and 5. The smallest number here are 2 and 2. For 6 and 8, we do the same thing. The multiples of 6, we have them already on the left side, 1 and 6, 2 and 3, and the multiples of 8 are 1 and 8, 2 and 4. Again, the smallest for the 6 and the 8 is 2. And then 2 and 5, we have the multiples of 2 are 1 and 2, and the multiples of 5 are 1 and 5. The smallest one here is 1. So for today's objective, by the end of class today, you should be able to solve systems of linear equations in 2 variables by elimination. You should also be able to compare and choose an appropriate method of solving systems of linear equations. Now, the appropriate methods, you only know 2 so far. You know substitution, which is what we did last class, and today we're learning elimination. So another method for solving system of equations is elimination. Like substitution, the goal of elimination is to get one equation that has only one variable. So again, solve for one and then solve for the other. So remember that an equation stays balanced if you add equal amounts to both sides. So if you consider this system, x minus 2y equals 19 and 5x plus 2y equals to 1. Since the 5x plus 2y equals to 1, you can add 5x plus 2y to the other side of the first equation and add 1 to the other side of the balance, and the balance is maintained. So all this is saying, if we have, let's say, x plus y equals to 1, if we add a 3 on this side and we add a 3 on this side, it's still going to stay the same. Now, this is just a lot of words, this last paragraph, for that. If you were to subtract, make it a negative 3, it's still, as long as you do it to both sides, it's still going to be balanced. This is all that it's saying. Why is it saying this? Because you have to move things around when it comes to elimination. A lot of the times it doesn't just come straight forward. So since we have a negative 2y and a positive 2y, and they have opposite coefficients, the key word right here is being opposite. You can eliminate the y by adding the 2 equations. The result is one equation that has only one variable, 6x equals to negative 18. How do they do that? So we have these 2 equations from the last slide, right? And they're adding them as if they were just a normal addition. The key thing here, though, is you can only add the x's with the x's, the y's with the y's, and the 19 with the 20, or the constants with the constants. So when we add 5x plus x, we're going to get 6x. When we add negative 2y plus 2y, we're going to get 0. And when we add 19 plus 1, we're going to get 20. That's where the 6x minus 18 comes from. Sorry, it was supposed to be negative 19. So this is minus 18. I wrote it wrong. That's where that 6x equals to negative 18 comes from. Now, when you use the elimination method to solve an equation of a system of linear equations, we want to align like terms in the equation. Then determine whether any like terms can be eliminated because they have opposite coefficients. Now, guys, if by any chance you're missing a coefficient and you have, let's say, 6x is equal to 3 and negative 6x plus 2y plus y is equal to 4, the way you would align this is you would do 6x plus 0y. We're going to write it as equal to 3. And then we're going to do the 6x plus y is equal to 4. Now, that way, the x's cancel out, and we're able to add the y's into 1 is equal to 7. So 1y is equal to 7. So sometimes you're not going to have both variables, but you can still line them up by putting a 0 in front of the variable. So for solving system of equations by elimination, we have a few steps. The first step is to write the system so that like terms are aligned. So what I showed you guys, x plus y equals a constant. They could be in any form, but you always want to make sure the x's are aligned with the x's, the y's with the y's, and the constants with the constants when it comes to adding them. Now, obviously, to eliminate them, you need one to be positive, one to be negative. For step 2, we have to eliminate one of the variables and solve for the other variable. So if we wanted to eliminate y right here, we need a positive y and a negative y. So they would cancel out when we add them, right? So we will get 2x is equal to whatever the constant is. So I'm going to say 2c. And they want us to substitute afterwards. After you get the variable, you're going to substitute it back in like we've been doing for the last section. And you're going to be able to solve for the other variable and write your answer in an order pair, x comma y. This is your order pair. So for this example, we're going to solve by elimination. So we have two equations. We have the equation 3x minus 4y is equal to 10. And we have the equation x plus 4y is equal to negative 2. So the first step is to align like terms. In this case, it's already given to us, align the x with the x, the y with the y, and the constant with the constant. Now, we notice that the y's we can cancel out because one is positive 4y and the other one is negative 4y. So when we add these, we're going to get 4x plus 0y is equal to negative 8. Sorry, to positive 8. I don't know why I keep writing negatives when I shouldn't. Now, I'm going to rearrange it as 4x is equal to 8 because the 0y doesn't do anything to us. It made the term disappear. Now, afterward, we're going to simplify and solve for x. So we're in step 3. We're going to divide by 4 on both sides, and we get that x is equal to 2. So after we solve for x, so we did step 1, step 2, step 3, we want to plug that 2 into one of the original equations. So again, write one of the original equations. I'm not going to rewrite them because they're the same. And then so they're already written for us. And for step 5, we substitute. So I'm going to grab that 2, and let's say I'm going to plug it into here. Again, doesn't matter which equation you plug it into, as long as it's one of the originals. So I'm going to go ahead and do 2 plus 4y is equal to negative 2. I'm going to subtract 2 on both sides to get 4y is equal to negative 4. Divide by 4, divide by 4. And we get y is equal to negative 1. So after we substitute, we solve for the other equation, and we only have one step left, which is to write the solution as an order pair. Now the order pair is 2 comma negative 1, and we are done. That would be our solution for this equation. So for this example, after giving you guys a few minutes to work on it, let's go ahead and solve it. I'm just going to rewrite them. So after I rewrote them, I noticed they're already aligned, so I can go ahead and add them. So after adding the y's, I get 3y. The x's cancel out, so I'm left with plus 0x. And the 14 minus 2 is equal to 12. So then I get 3y is equal to 12. I'm going to divide everything by 3. So I end up with y is equal to 4. So I did the first few steps. Now I'm going to go ahead and plug the 4 back into the original equation. I'm just going to plug it into the first one. Honestly, it doesn't matter which one you plug it into though. So you get 4 plus 3x is equal to negative 2. I'm going to subtract 4 on both sides. And we get 3x is equal to negative 6. I'm going to divide by 3 on both sides. And I get that x is equal to negative 2. So after finding both pairs, I get my solution to be negative 2 comma 4. I'm going to rewrite that 4 because it looks kind of ugly. So when two equations each contain the same term, you can subtract one equation from the other to solve the system. To subtract an equation, add the opposite of each term. So what I always like to say, guys, what this means is if you have a negative and a positive, at the end of the day, you're always subtracting it and keeping the sign of the biggest number. But if you have, if you're doing elimination, so what I always prefer to do, guys, I always prefer to add the equations and then just subtract those two terms. There's a lot less work involved when it comes to that because you're more constant in what you're doing. So for this one, I'm going to start by writing them out again. You don't have to write them out all the time, but it helps. So I want you guys to notice, here the x's are the same term, right? But they're both positive. So when it says to subtract them, what I personally prefer to do, which is still a subtraction, I'm going to multiply the whole thing times negative 1. So we're going to get negative 2x plus 5y is equal to negative 13. So I'm going to rewrite those equations like that. So 2x plus y equals negative 5. And negative 2x plus 5y is equal to negative 13. Now I'm going to go ahead and add them. So 2 plus negative 2 is 0, x. 5y plus y is 6y. And negative 13 plus negative 5 is negative 18. Now the x disappears, so I'm left with 6y is equal to negative 18. I'm going to divide by 6 on both sides, so I get that y is equal to negative 3. Now I'm going to grab that negative 3 and plug it into either equation. I'm just going to choose the first one because it's on top. It really doesn't matter which one you plug in though. So we're going to do 2x. Doesn't matter which one you plug in as long as it's the original. So 2x minus 3 is equal to negative 5. I'm going to go ahead and add 3 to both sides. So I get 2x is equal to negative 2. I will divide by 2 on both sides, and then I'll get x is equal to negative 1. So my final order pair is negative 1 comma negative 3. So this would be my answer. So I haven't been doing this throughout the problems, but we can always check our answers by substituting them back in. Kind of like we had on the quiz, we had an equation, let's say x plus y equals to 3, and 2x plus 3y is equal to 6, for example. So we can solve it and check the answer by plugging the order pair back in. The order pair that we found into the original equation. So for this example, we're going to have to do what we did in the other one. We're going to have to multiply one of them by negative 1. I'm going to rewrite both of them. Now, since I can get rid of one of the y's, I'm actually just going to go ahead and multiply. Since we did the bottom equation, the other problem, I'm going to multiply the first one. To show you guys it doesn't matter which one you multiply by. So we're going to do negative 3x minus 3y is equal to negative 15. So after I get the negative 3x minus 3y equals to 15, I'm just going to write it right under the other equation. And now I can add them. So we're going to get negative 2x plus negative 3y as negative 5x. The y's cancel out because we have a positive 3y and a negative 3y. So I'm going to say plus 0y is equal to negative 20. Then I'll go ahead and rewrite it without the 0 because it cancels out. Then I'm going to divide by negative 5 on both sides. And that's going to give us that x is equal to 4. I will grab that 4 and plug it into either equation. Again, it doesn't matter which one. I'm going to plug it into the first one just because it's on top. It's really, there's no preference. 3 times 4 plus 3y is equal to 15. So I get 12 plus 3y is equal to 15. I'll subtract by 12 on both sides and get 3y is equal to 3. Then I get y is equal to 1. So we get the order pair of 4, 1. Now, I'm going to show you guys how to check it since we had the reminder in the last slide. So I'm going to plug the 4 and the 1 into both equations. Again, the original. So if I do 4 times 3 plus 3 times 1 is equal to 15. So it's going to get 12 plus 3 is equal to 15. So 15 equals to 15. It works for the first equation. I'm going to do the same thing for the second. So negative 2 times 4 plus 3 times 1 equals negative 5. So I'm going to get negative 8 plus 3 equals negative 5. So I get negative 5 is equal to negative 5. So it works for both. That way you know you got the correct answer. You don't have to check them, but if you have time, I always recommend it. Alright guys, since we're out of time for the class, I'm going to stop the notes here and we will continue tomorrow. Please go ahead and turn in your notes up to this slide. So in some cases, you will first need to multiply one or both equations by a number so that one variable has opposite coefficients. So like we did last slide, we multiplied one of the equations by negative 1 in order to cancel out the term. Now sometimes you're going to have to do a little bit more than just times negative 1. Let's go over it so I'll show you. So in order to solve for this equation, the instruction says to multiply each term in the second equation by negative 2 to get the opposite y coefficient. Now, you don't have to do that. You don't have to cancel out the y first. You don't have to cancel out the x first. Whichever you prefer to solve for, that's fine. There's really no way to go about it wrong as long as you do the correct steps. So, in the other class, I actually ended up canceling y. So I'm going to do this one canceling x. So you guys have both. So if I were to actually multiply by 3, this first equation, I end up with 3x plus 6y is equal to 33. Now, I want you guys to notice something. The reason I multiplied the first equation by 3, and I didn't follow the instructions of multiplying by negative 2, is because the x's already have a positive and a negative. So because I already have a positive and a negative variable, it just makes it easier as I don't have to worry about signs. Now, when I add those two, the x's are going to cancel out, so I'm going to get 0x plus 7y is equal to 28. I'll divide by 7 on both sides, and that's going to leave me with y is equal to 4. Afterwards, we're going to end up substituting back in, again, to the original equation. You guys have heard me say original equation for this chapter, and I think for a few other sections, a lot. And it's because of this. In this case, we modified the equation. In a lot of the cases, we will modify it. So it's just good to be able to plug it in back into the original. I'm going to plug it into the first one. I'm going to get x plus 2 times 4 is equal to 11. So I get x plus 8 is equal to 11. I'll subtract 8 on both sides and get x is equal to 3. So I get a variable of, or an order pair of 3, 4. Now, like I mentioned in the other class, for the quiz, I didn't take points off if you left your answer like this. But for the test, you must put it in an order pair, especially since the instructions did say to put it in an order pair. Now guys, if you would have followed the instructions and solved and cancel out the y first, then you still would get the same answer. It wouldn't have mattered. Now I'll do another problem following the instructions, canceling out the other one so you guys are able to follow with it. So for this problem, since there is nothing I can multiply one or the other, to cancel it out, I'm going to actually have to multiply both equations. I'm going to have to modify both. Now, as a tip, if you already have a variable that has a negative and a positive, I would just go ahead and multiply to get rid of those, making it easier as you don't have to worry about signs because you know they're already going to cancel out. Now, I'm going to multiply the top equation by 2 and the bottom equation by 5 so I can cancel the x's. So we're going to get negative 10x plus 4y is equal to 64. Now I'm going to multiply. 5 times 2 is 10x plus 15y is equal to 50. Now I'm going to go ahead and add them. The x's cancel out, so we're left with 0x to 19y is equal to 64 plus 50 is 114. Now I get 19y equals 114. I'm going to divide by 19 on both sides, and that's going to give me that y is equal to 6. Now I'm going to go ahead and plug that into the original equation. Again, either one doesn't matter. I'm just going to plug it into the second. So 2x plus 3 times 6 is equal to 10. So I get 2x plus 18 is equal to 10. I'm going to subtract by 18 on both sides. So I'm going to get 2x is equal to negative 8. I'm going to divide it by 2 on both sides, and I get that x is equal to negative 4. So again, your ordered pair answer is going to be negative 4, 6. This problem, the instruction is to multiply each term in the second equation by 3 to get the positive x coefficient. Now, that's what I would have done either way without the instruction, because again, following the same tip, the x's have one positive and one negative. So if I multiply everything times 3, we're going to be able to cancel out the x. I'm just going to go ahead and rewrite the first equation. And I'm going to rewrite the second equation after multiplying everything by 3. After we get the distributing part, I'm going to go ahead and add them. So the x's cancel out, so I get 0x plus 5y is equal to 0. So we're going to get 5y is equal to 0, divided by 5 on both sides, and we get that y is equal to 0. 0 is an answer, and it's 100% possible. Now you can plug it into either one. I'm going to plug it into the second one, just so you guys have something or see something that we haven't seen in a little bit. What is that? The thing we haven't seen in a little bit is, obviously when I plug it in, we get that y is equal to 0. So we're left with negative x is equal to negative 2. This is what we haven't seen in a bit. I wanted to remind you guys that when you have x equals to something, you want to make sure the x is positive. So I'm going to divide both sides by negative 1 so we can cancel out that negative. We get x is equal to 2 because it also cancels it out for the other term. So we're left with 2, 0 for the answer. So for this problem, following the same advice as before, we have a negative x and a positive x, one being 3 and one being 2. Now there's nothing I can do for only one equation to cancel them out. So I'm going to multiply the top one by 3 and the bottom one by 2. So I'm going to get 6x plus 15y is equal to 26 times 3 is equal to 78. Negative 6x minus 8y equals negative 50. So after distributing all of the terms, we're going to go ahead and add them. That's going to cancel out our x's to 0x plus 7y is equal to 28. So we're left with 7y is equal to 28. I'll divide by 7 on both sides and get y is equal to 4. Now I'm going to go ahead and plug them into either equation. Doesn't matter which one as long as it's the original. So I'm going to plug it into the first one just because it's on top. So 2x plus 5 times 4 equals to 26. So we're left with 2x plus 20 is equal to 26. I'll subtract 20 on both sides. And I'm going left with 2x is equal to 6. I'll divide by 2 on both sides, and we get x is equal to 3. So we get our answer to be 3, 4. Now, I want you guys, usually I haven't been checking them for today, but I want to show you how it would be if you were to check them. So we're going to grab the 3 and the 4 and plug it in. So we're going to be left with 2 times 3 plus 5 times 4 equals to 26. So it would be 6 plus 20 equals to 26. So we get 26 is equal to 26. So that way we know it works for the first one. We're going to plug it into the other one. So we're left with negative 3 times 3 minus 4 times 4 is equal to negative 25. So we're going to get negative 9 minus 16 is equal to negative 25. These end up adding to negative 25 is equal to negative 25. So you know it works. Now, if in the test you have time, please check them. I'm not going to ask, like, even if the instruction says check it, that's just for your convenience. If you show me the work and you got the right answer, then by all means you'll get the points. But if you have time, do go back and check. That's something I cannot stress enough. It would be in your convenience to do that. So this last slide for this PowerPoint, guys, it's a summary of the 3 ways you can solve for a solution for 2 linear equations. The first one is graphing. That was 6.1. The second one is substitution. That is 6.2. And this third one is elimination, which is 6.3. Now, it is important that you know how to do all 3 because these 3 sections will be on your test. Now, graphing, it will be like your quiz. You'll get a graph, and you have to tell me what the answer is just by looking at it. Substitution, it's the way we did it again on the quiz, where you grab a variable, plug it back in, solve for one. After finding the answer, plug it into the other variable and solve for it. Now, elimination is what we did today. You guys will get back your quiz on Monday. You do have homework today, but it is important that you guys know how to do all 3. Unless the instructions specifies substitution, graphing, or elimination, you guys are free to choose whichever method you prefer. But if the instruction says to solve by substitution, or solve by elimination, or solve by graphing, you must follow the instruction. If you don't follow the instructions, even if you get the right answer, you won't get full credit for the question. Again, that's only if the instruction says it. If the instruction doesn't say it, by all means, choose the way you think is best or the one you like the best. Since there are no questions, we have about 2 minutes left in class. We'll just stop here. And you guys do have homework. You're welcome to start on it for the last 2 minutes until the bell rings.